All right, guys. Before we get started, questions on the homework. Questions on each of the homework assignments. Questions on the homework. All right, guys. Questions on the homework. All right, guys. Questions on the homework. Okay. Everybody have a graphing calculator. So what we're starting today is 4.6. This is the last section we're covering in chapter 4. And the first thing we're going to talk about is the fundamental theorem of algebra. So if we look at this chart here, it tells us a few things. One, if we have the equation 2x minus 1, well, the degree is 1 because the biggest exponent attached to the variable is 1. It works out that the solutions for this first equation is 1/2. So the number of solutions is 1. The next one, 2x squared minus 2 equals 0. The degree is 2. The solutions for this are actually plus or minus the square root of 2. So we have 2 solutions. Our third equation here is x cubed minus 8. Since the biggest exponent attached to the variable is 3. The degree is 3. The solutions actually work out to be 2. -1 plus or minus I squared of 3. So we have a total of 3 solutions. And lastly, we have x cubed plus x squared minus x minus 1 equals 0. Degree is 3. The solutions work out to be -1, -1, and 1. So the number of solutions is 3. So we have this here. And this really leads us into the fundamental theorem of algebra, which the first part states if f of x is a polynomial function where the degree is greater than 0, so it actually is a polynomial function. Because if the degree was 0, that means we just have, okay, apparently, oh, there we go. F of x equals 6, just a number. We don't have variables. So the degree, we have to have a variable. That's all that first part's saying. Then the equation f of x equals 0 has at least one solution in the set of complex numbers. So if it is a polynomial function, we have at least one solution in the set of complex numbers. Really all that's saying is a is equal. So if we said a is equal, x is equal to 7 is the solution, it's now a complex number. Really doesn't say a whole lot. But the second part, the corollary, if f of x is a polynomial function degree n, where n is greater than 0, then the equation has exactly n solutions, provided that each repeated solution is counted as many times as it is. So each repeated solution twice is counted twice. Each repeated solution 3 times is 3 times, and so on. N is our degree. So what that means for us is, if we look at this one here, x cubed plus 3x squared plus 16x plus 48 equals 0. How many solutions does this have?
1, 2, 3, 4.
So what's the degree? Guys, up here. The degree is what? So how many solutions should it have? It has 3 solutions. And specifically, those solutions, if we were to solve it, are -3, 4i, -4i. So the number of solutions is 3. How many zeros does this one have? 4. If the degree is -2, -2, -2, and 0. So even though -2 shows up 3 times, we have to count them as individual solutions. But the number of solutions is 4. So the degree and the number of solutions are going to be the...
So that doesn't tell me everything else.
All right, guys. Let's focus up here.
So, where do we get to?
No, that's just the solutions.
Where do you get
Solving. like, so all the steps we did last week was solving and finding them. I'm just giving, no, I'm just, at this point, we're just saying how many does it have. If we went through and found them, it would be those there.
I felt there was like a lot more to it that I was just completely missing.
No, we're just determining how many zeros does it have. Here, it has 4. How many solutions does this equation have? 4. How many zeros does this one have? 3. Okay. Now it wants us to find all the zeros. Now we actually have to do some steps in solving this here. In building up to this, really, when we went through solving these, we had different methods to get there, different ways to solve it. But the number of zeros that this should have, number of solutions this should have is what? 5, because the degree is. So if we solve this and once we find 5 zeros, we know we are done because we need 5 solutions. And we went through different ways to find this. We can do the rational zeros, so we can find all the rational zeros for this here and test them one at a time. We can try to factor. But I have a feeling the first main way we want to do this is by graphing. So if we graph this here, x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. So I'd make sure that y'all are able to type this in. So I'd type this in. And again, we're looking for 5 places that it crosses, because if we can find 5 solutions to this here,
Just type in the right here.
example 2, yeah, find all zeros. Yep, so we're typing everything in there. Now, one of the main things that we need is that it equals 0 half f of x. So it'd be preferable if we had 5 solutions. We need 5. But since it is degree 5, if we can get at least 3, we have enough to get it down to a quadratic and solve from there. Questions on? So the button above the division key, and then we can type the number in. Questions on how to type this in? No?
Yeah, how do you type it in?
Y equals?
Like, do all that when you graph.
Mm-hmm.
My graph should look like cool.
X button is next to alpha. The button above the division gives you the ability to type an exponent in. Then you have to use the arrow key over. It's also on your paper. So everybody able to get this typed in? And when we hit graph, did everybody get something that looks like this here?
Yeah.
Yep. So again, we're looking for what value of x will make the function equal what? 0. So if we go second graph,
Well, I might start way up there.
so they'll start at different points, but here we're looking for it at 0. So we have -1 and 2.
Yes.
Now part of the reason is, again, I always go to the graph first, is to get an idea, see where it's going to cross. Because -10 to 10, it gives me an idea of what values to be looking for. Here, we know one's negative, one's positive. So -1 and 2. So we know for sure that x is equal to -1 and x is equal to 2. Now at -1, we did see that the graph came up, touched the x-axis, and went back down. It looks like it might not have crossed there. So there's a chance that -1 might work twice. Because anytime it touches the graph but does not cross, means that 0 is going to show up more than once. Now we could plug the numbers in across the top, so our coefficients in front of the variables. So 1 for x to the 5th. Since there's not an x to the 4th term, it's going to be 0. X to the 3rd would be 1. X squared is negative 2. X is negative 12. And our constant term is negative 8. Questions on how we set the synthetic division up?
Why is the second one 0?
Since we don't have an x to the 4th, because we need one for each term.
Right. I didn't see it. I didn't know that. Okay.
Yep. Any other questions on this here?
0, 1,
And the main reason, guys, we're doing this here is to decrease the degree, because each time we divide by one of these solutions, we decrease the degree by 1. Because if I can get it down to a degree 2, we can solve from there. Which of these two solutions do we want to try first? And we're going to go through our steps for synthetic division. So it's going to be 2 times 1, which is 2. 0 plus 2 is 2. 2 times 2 is 4. 1 plus 4 is 2 times 5 is 10. Negative 2 plus 10. We could have. Yeah, it doesn't really matter which one we do first. 2 times 8 is 16. Negative 12 plus 16. 2 times 4 is 8. And negative 8 plus 8 is
0. Hey, it
0.
went right.
Yes, because if it is a solution, we should have 0. Since the calculator told us it was a solution, we should get a remainder of 0. Then we can do negative 1 next. Negative 1 times 1 is negative 1. 2 plus negative 1 is 1. Negative 1 times 1 is negative 1. 5 plus negative 1 is 4. Negative 1 times 4 is negative 4. 8 plus negative 4 is? And negative 1 times 4 is? 4 plus negative 4 is 0. Questions on this so far? Because at this point, the degree is 3.
Oh, yeah, you did say we could do negative 1.
More than once. Because if it touches that x-axis, if it touches the x-axis of the graph but does not cross it, it's most likely going to have an even multiplicity. It's going to show up more than once. So we can try negative 1 again. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Negative 1 times 0 is 0. 4 plus 0 is 4. Negative 1 times 4 is negative 4, and 4 plus negative 4 is. So that does tell us that negative 1 worked twice because it gave us another 0. We can try.
I'm guessing it won't because you were going to quit right there.
It won't. Because if we try this again, negative 1 times 1 would be negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. Giving us 5. Doesn't hurt to check. So, questions on how we got to this point here? So we use the graphing calculator to find the solutions, as many as we can. And from here we can plug the variables back in. Now the last number is our remainder, our 4 is our term without x, 0 is our term with x, 1 is our term with x squared. So what that tells us is that what we're left with is x squared plus 4 is equal to 0. Now this part's kind of nice, because since we don't have a middle term, we don't have x,
How did you do over the 0?
r,
Okay.
because it's our remainder.
R?
So the last number, the number in the box, is always that remainder.
X squared.
Now since we don't have a middle term, we can get the x squared term by itself. Here we just have to subtract 4. And once we get it by itself, we can take the square root of both sides. And the square root of x squared is x is equal to plus or minus. Because whenever we take the square root of both sides, we have to have the plus or minus. So what we're doing is the square root method. So to find the last two answers, we need to solve it. If there's a middle term, we have to use the quadratic formula. Here, because there is no x term, it ended up being 0 here, we can use the square root method. We get x squared by itself, take the square root of both sides.
2,
Yes.
because it has a negative.
The negative is going to come out as I, and the square root of 4 is 2. So we get positive 2i and negative 2i. So that is two solutions with the 3 we had before. Does give us a total of 5. And how many solutions did we say we needed for this one here? Did we find all 5? That's it. From solving the x squared plus 4. Because the 2i, because really we have positive 2i and negative 2i, so that is two solutions, negative 1, negative 1, and 2.
Under the radical form, take it out, it's I. Can't put it in radical form.
Yep, we can't take square root of a negative.
So you take the negative out, change it to I, and then you have radical of 4. So you find square root of 4, which is 2, and you get 2I.
Yep. Any other questions on this here? Questions on this here? Because even if we didn't get the 2i part, you still get 3 out of the 5 just from graphing this one. All right, let's look at this one here. X cubed plus 7x squared plus 16x plus 12. Again, guys, I'd grab the graphing calculator and type this in. Again, it'd be good getting practice typing these in, because if you do have questions, you can ask.
Oh yeah, this one as well.
Yep.
Clear, or
X to the third plus 7x squared plus 16x plus 12.
plus 16x plus 12. And then second graph.
So you can do yes, or just graph. Graph will give us the graph of it. Second graph,
goes to the other form.
the table. Because it'd be good to look at the graph itself just to see where it's crossing, where are possible solutions. Second graph will give us this more easier to see numbers.
You just press graph.
Yep. So you get something that looks like this here. At the top. Top right.
It's like right under the screen.
Yep. Yep. Let's go second graph. So our two solutions that he gave us was -3 and -2. How many are we looking for? 3. So here, because the degree is 3, we should have 3 solutions. Because it was -3 and -2, yes? Yes. Now, yes. Now with any of these here, because the degree is 3, we should have 3 solutions. The best situation, the best case is that we find 3 solutions by graphing. Next best is to find 2. Here, the absolute minimum we need to find is 1, because we need 2 less than the degree. So, or 1 less than, yeah, so we need to get it down to a degree 2.
So no matter what the degree is, there's that many.
So if it's a degree 5,
Is it always for the first one, or is it just the highest thing?
so the degree is the variable with the biggest exponent. Normally, yes.
Biggest exponent, or if it was just a 1?
So normally, so, all right, guys. So the question is the degree always the biggest exponent or the one in front? And if it's normally both, because if it's written in standard form, the variable with the biggest exponent should always go first. So that's why it's easier to see. But if it's not written in standard form, then yes, it is the variable with the biggest exponent. So here it's 3. Now, what we want to find by graphing is to get enough solutions to get it from a degree 3 down to a degree 2. So here we would need at minimum 1, at best 3.
16.
So 2, -2, -3. So if we write out the top, it would be 1, 7, 16, 12. Which one do you want to use first? -3. Doesn't really matter which one we use first. We're just going to have to use both of them. -3 times 1 is -3. 7 plus -3 is 4. -3 times 4 is -12. 16 plus -12 is 4. -3 times 4 is
-12.
0. And that's what we expected. Now at this point here, we could solve this using the quadratic formula, factoring, using those there. But since we do have another solution, might as well use it and get down to a simpler equation. Because -2 times 1 is -2. 4 plus -2 is 2. -2 times 2 is
4.
0. So now we can go on and plug the variables back in and solve for the last one, because we have 3 solutions that we need. We've only found 2. Now the remaining equation after the synthetic division is going to be x plus 2. Now to solve x plus 2, we would subtract 2, telling us x is equal to
Plus 2 equals 0, minus those.
So -2, -2, -3 are the 3 solutions here. Questions on this here? Let's look at the next one.
This one's gonna have 5.
So it's going to have 5 solutions. At most, we need 3, because if we have 3 solutions, we can get it down to a degree 2. It'd be even nicer if we can find 4. In the case that we would like the best is if we have all 5. X to the 5th minus 3x to the 4th plus 5x cubed minus x squared minus 6x plus 4.
Yeah, okay, it showed up.
So -1 and 1.
Have you been putting it in whenever? Yeah. The y equals, you put the whole thing in the graph.
I put the right, I put the last one correctly. It's just like,
So y equals. So click y equals. Clear. Now type the new one in. All right. Now looking at this here, we do see that negative, or at 1, it touches the graph and goes back up. So there's a chance that 1 might be repeated twice. So we do have at least 3 solutions. Which one do we want to try first? We can do 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is? All right, guys, let's focus in here. 5 times negative 2 is 3. 1 times 3 is? Negative 1 plus 3 is 2. 1 times 2 is 2. Negative 6 plus 2 is negative 4. And 1 times negative 4 is negative 4. Now, again, we said there's a chance that 1 might work twice. So let's go on and try it again. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. 3 plus negative 1 is 2. 1 times 2 is 2. 2 plus 2 is 4. 1 times 4 is 4. And negative 4 plus 4 is indeed 0.
Oh my god.
So it's 1 twice.
3 1.
Yes.
It's okay, we still need 2 more.
So now we're going to,
4 1s, I bet. Probably another negative.
so we're going to do negative 1. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is 2. 2 plus 2 is 4. Negative 1 times 4 is 0. So we have, if we put the variables in at this point, we would have our x squared x, so x squared minus 2x plus 4. So just by graphing what we have left, it doesn't cross the x-axis, so negative 1 and 1 aren't going to work anymore. But because we do have a middle term this time, we're going to have to use the quadratic formula. A is the number in front of x squared. B is the number in front of x. And C is our term without a variable. So we're having to use the quadratic formula to solve this here. Our B term is our term, and here our value is negative 2, plus or minus the square root of negative 2 squared, minus 4 times A, which is 1, times C is 4. All over 2A, so 2 times 1. Now we need to do some simplifying before we can call this one finished. Our negative 2 is going to become positive 2. On bottom, our 2 times 1 is 2. Now we can type everything inside that radical, guys, into the calculator. So our negative 2 squared minus 4 times 1 times 4. So negative 2 squared minus 4 times 1 times 4 is negative 12. Now the 30xs cannot simplify negative 12. But we can, because that negative is going to come out as I, leaving us with the square root of 12. Guys, focus up here. If we look at the square root of 12, we get 2 square root of 3. So the square root of negative 12 is 2i square root of 3. Questions on this so far? Is there a common factor between all three terms? The two terms on top and the bottom? 2. We can divide all these by 2, because our first one, 2 divided by 2 is going to be 1. Our 2i divided by 2 is going to be I. Square root of 3.
Divided by 2.
Because really,
Yeah.
really what we've done is split it apart to 2 over 2, plus or minus 2i square root of 3 over 2. And both of those simplify down. The 2 over 2 becomes 1. The 2i over 2 becomes I. And we get this here along with our negative 1, 1, and
Wouldn't it be 1i?
1i or I, yes.
So it's just 1i but gone.
It is, yes. So it is 1i. We just don't have to write the 1i. So those are our last two, along with the 3 we found from graphing.
So 1 plus or minus I square root of 3.
Yep. Because 1 plus or minus I squared of 3 is technically 2 answers. Because,
1 plus I, 1 minus I.
yes. Because it's just a simpler way to write the plus or minus so we're not having to write it out twice. Questions on any of this so far? All right. The next theorem that we have is the complex conjugate theorem. All this is saying is that if a plus bi is a solution, as we just saw, 1 plus I squared of 3 is a solution, 1 minus I squared of 3 is also a solution. If we have one, we have to have the other. All complex solutions, all solutions with I come in pairs, just like our radical, our irrational solutions. If we have one, we have to have the other. And we're going to finish this